peace, serenity. I hope you know. I hope you know that this is nothing to do with you.
Hey, what's up, Precal12? Hey, I got bored tonight, so I thought, hey, what the heck? Let's do a little bit of Fergie, Big Girls Don't Cry podcast. Why not? 5.3 is due tonight. I know that. And I couldn't help but think that there were a couple things that, if I was honest, I probably could have taught a little bit more clearly and probably slowed down a little bit more through some of this stuff. So because of that, I wanted to make it up to you, try to make a podcast for those of you who are either A, studying for the test, or B, you could be just working on the homework tonight and needing some extra help. So what I did was I took 3 problems off the homework here. And so check this out. Hopefully it will help you. I do not have my writing tablet today, so I'm doing everything by hand. I love you all so much that, again, I just want to make sure we're all good for that 5.3 homework tonight. So check this out. And if you got any questions, shoot them my way and we'll go from there. All right. Let's rock and roll. I do want to go through these 3. These are the 3 that kind of stuck out to me. And as I looked online, there was actually a different way to teach it, which I kind of liked a little bit better. And so notice all of these, we call them multi-angle, multiple angle. It's because the 2, the 3, and the 1/2 here kind of lend itself to where you have multiple angles. You have more than just one angle. You're going to have multiple sets. Now, I taught it where, like, if this is 3, you'll have 3 different sets, 2, 2, and then obviously so on and so forth. Online, I know it was correct, but online they actually taught it better. And I'm going to teach it their way because I think I like it a little bit better there. So what we're going to do is we're going to teach this this way. We're going to actually say this. I want you to solve this as if this 3 right here was not even there. So what would be tangent of x equals 1? So in fact, what we'll do, we'll get some connectors here. Let's see if we can go here. Well, we know that tangent would be 1 in this quadrant, right? And it would actually be at 45-degree angle right here. This would be a 45-degree, or we'd say pi/4, right? We also know that all short teachers care. Okay, I'm very offended by that, but that's true. All short teachers care. And so because of that, what we're going to do is we actually have, it's actually positive in the first and the third quadrant. So because of that, that means that at pi/4 and at 5pi/4, those are the 2 places where tangent is going to be 1. So what we're going to do is we're going to list those out. So we're going to say pi/4 and 5pi/4. Now, you'll notice that with tangent, I mentioned this in the class, anytime you have tangent, you really only need the values that are in quadrants 1 to 2, whether it's cotangent or tangent, because and this is only, again, only for tangent and cotangent, because the period repeats itself over the course of pi. So like if I added pi to pi/4, I'd get to 5pi/4. So actually 5pi/4 is redundant, is really what's happening there. But I understand what we're saying. I get what we're saying, and I'll allow you to put that. Just remember that with tangent, we're actually adding pi n, okay? So each of these, we're going to add pi n. Again, just like I said, if I put 1 in for n, it's really redundant, and if I continue to do that, it would just keep following. It's kind of the same pattern there. And if I add 5pi/4 plus pi n, I'd get back to this one. So really, I only need the top one, but I'll put both in just because it will follow the same pattern or similar pattern as sine and cosine there. So here's the thing. The only difference with this is this. And by the way, how did I get pi/4 and 5pi/4? Because when I do y over x over here, when I do y over x of square root of 2 over 2 over square root of 2 over 2, I'll get a value of 1. So that's just a heads up there. So now in each of these, I'm going to set this equal to 3x. And we're going to do that for both of these, okay? Set these equal to 3x and set them equal to both. So we're going to actually get rid of this 3 by multiplying by 1/3. So once I do that, I'll multiply by 1/3 here and over here. So I just continue. And I'm going to do the same thing here. Now, one thing you'll notice is that I don't have 3 sets, right? Really, I only have 1 set. What happens is when I multiply by 1/3 to both parts, now this pi n right here, when I multiply by 1/3 to that part as well, it will build in the 3 sets to where I don't have to do it. So once I get this, I'll get pi over 12 plus, and I'll set this equal. So my answer really should be pi over 12 plus pi n over 3. And again, I could put the second one in. The second one, by the way, this would be my answer, right? The second one would be 5 pi over 12. 5 pi over 12 plus pi n over 3. And again, like I said, if I rotated this, this would, I mean, the top one actually will build this one in because it's tangent, right? So tangent, you only need first and second quadrant, but you can't have this too, just in case you wanted to be consistent as you did with sine and cosine. Let me explain this. Hopefully this will help you in doing the sine and cosine one here. So let's do this one. We're going to divide by 2 here. Actually, there we go. We're going to divide by 2, and we're going to make sure that sine is by itself. The problem, though, is that once I get this, I see that sine squared 2x equals 1/2. So we're going to square root both sides. And I'll tell you, this is probably one of the tougher ones on there. But you'll notice that once I do get to this, I'll get sine on the left side, really sine of 2x, right? So what I'll do is I'll put sine of 2 and then x equals 1 over, and by the way, the square root will go to the top, right? Square root of 1 is 1, and then the square root of 2 we'll just keep as the square root of 2. So we want to rationalize this in order to make sure we have this correct. So we're going to multiply top and bottom by root 2 to get root 2 over 2. Now, I know a lot of people within second period kind of were struggling with this part too. It's kind of reminding ourselves that when I square root a squared, remember that the opposite side will end up having a plus or minus. So now instead of having 2 values, the plus or minus allows us to have values at all 4 sides. So it should be 1 here, over in quadrant 2, quadrant 3, and quadrant 4. So where is sine going to be square root of 2 over 2? Positive and negative. Well, again, you'll notice that all of these values will have the pi over 4 in it, right? So the y, where it's square root of 2 over 2 would be pi over 4. I'm going to take a little bit to do this, but we're going to do pi over 4, 5 pi over 4, I missed one, 3 pi over 4, and 7 pi over 4, okay? And 7 pi over 4. Now, for sake of room, and because I'm trying to do this by hand, one thing you've got to remember too is that each of these is going to be added. We're going to add 2 pi into it, right? So we're going to add 2 pi into all 4 of these, all 4 of them. But because of the 2x, this is where we build that in, right? Before I told you, okay, come up with 2 sets, add 2 pi, all that. It becomes a little confusing. What I can do is once I get to this point, I can say on this, instead of it, just a little tweak. Let's take one, let's say 7 pi over 4 plus 2 pi n, okay? And what we're going to do is we're going to set, we'll do just this one just for sake of room and just so I don't have to hand do this because it does take a little bit. But I'm going to set it equal to 2x, and I'll do it for all 4 of these. Now, how do I get rid of that 2? I'm going to multiply by 1/2. Okay, so I'm going to multiply by 1/2. Perfect, 1/2 there and 1/2 here. So what I end up getting here is 7 pi over 8 plus, and then the 2's cancel, right? 7 pi over 8 plus pi n, and that would be equal to what my x value was. So 7 pi over 8 plus pi n, and that would be my answer. And I would do it for all of these. So this one would be pi over 8 plus pi n, 5 pi over 8 plus pi n, 3 pi over 8 plus pi n. And that's all I would do for that one there. So there'd be 4 different values. And instead of having 2 sets of things, it becomes a little less confusing if I just say, if I build that into the 2 pi n that's here, okay? Excellente. Now, I will tell you that if I did, so this is when we say, like for up here, right? Or down here, or up here, and then also down here. If I said, what are the values between 0 and 2 pi, one thing to remember is that this, in that case, I would have to find 2, right? If I found the values, but let's say that I didn't restrict it, right? If I just said find the value or solve for this, this is sufficient right here. But if I said find all of the values between 0 and 2 pi, I would have to find the two sets like I did in class earlier, because again, you won't have the pi n or 2 pi n to save you there on that. Okay, hoping that will help on that. All right, let's do this one. Perfecto mundo. All right, I could sing Fergie again. It's up to you. All right, so let's do this one. Where's cosine? Cosine by itself now. Where's cosine square root of 2 over 2? We know it's square root of 2 over 2 and we're talking x, right? It should be in quadrants 1 and 4. So the two spots that we have there should be at pi over 4. Well, that was a big pi, I'm sorry. Pi over 4 and I think it's 7 pi over 4. Should be the two places where it's square root of 2 over 2. And so in this example, very similar to the last one, we're going to add 2 pi n to both of them. And again, I put it once, but really on the test, put it twice. I just, again, don't have room here and trying to write that out. Sometimes it's a bear just with doing it by hand. So let's take the pi over 4 plus 2 pi n. So when I do pi over 4 plus 2 pi n, we're going to set it equal to what our angle is in this case, or the multi-angle in this case, x over 2. So this time we're going to multiply by 2 on both sides. Okay, so what we'll do, we'll multiply by 2 here. And we multiply by 2 here. So the 2 goes into 4 twice. So we should have pi over 2 plus, and then 2 plus 2 pi n would be 4 pi n. And that right there would be one of my answers for that. This one would be, if I multiplied this, it should be 7 pi over 2 plus 4 pi n. 7 pi over 2 plus 4 pi n. And again, that would be just finding any of my values there moving forward. So that's kind of what we're looking at on that. If I just said, hey, what's the one between 0 and 2 pi? There's only one going to be there, and that's going to be the pi over 2, because if I did it with this one, 7 pi over 2 would be outside of that 2 pi range. So but let's say I just said find the answers, then I would do 7 pi over 8, right? Because I'd multiply by 2 to be 7 pi over 8 plus 4 pi n. Okay. Hey, I hope that was helpful for you as you work tonight. Again, as I look at this, let's see if I don't think I've got, oh, I do. One of those was in the OT section. The first one was in the OT section, the tangent of 3x. The second one was in the second quarter. And then the first quarter one was, no, hold on. I want to make sure I hit that right. Where's that one at? Oh, yeah, and then the OT was the third one too. So both of these over here, those both are OT, and then this should be the second quarter on that side. Hopefully this was helpful for you as you look at it there. If you need some more help, we'll be reviewing next week, Monday, Tuesday, in preparation for the test.